Okay, now this is Kinematics for October-November 2016 variant 2 question. So here a car starts from rest, move along straight line from point A, constant acceleration is 3 for 10 seconds. For me, I like to draw it out so I can see the movement of the car. It starts to move from rest with a constant acceleration of 3. That means the gradient of this line is 3 for 10 seconds. Okay, so you can use what do you call that, simple gradient. Let's say v over t equals to 3 and find the velocity. So we know that the velocity of the car after 10 seconds is 30 meters per second. Then the car will start continue to move with a constant speed for 30 seconds. So 30 plus 10 is 40 before decelerating uniformly and coming to rest at point B. So this is point B. Let's say it's come to rest at t equals to t, a capital T. Now, you want to find the total distance traveled first 40 seconds. So I think we can just use area of trapezium, half sum of parallel side. Now this length from here to here will be 30. The height, then the parallel side will be 40 multiplied by height of 30. The result is going to be 70 divided by 2 times 30, 1050. So that's a total distance traveled in the first 40 seconds. So when the car has been moving for 20 seconds, the motorcycle starts from rest and accelerate uniformly. So let's say I put 20 here. It accelerates uniformly to a speed of v. So I'm going to put, let this be v. Okay, and then you maintain the speed for 30 seconds before decelerating uniformly comes to rest and v at b. That means it actually stopped at the same time, right? At the same total distance traveled here must be the same as total distance traveled by the car. So, but the thing is, we need to find what is the time here. We know the total distance traveled by the car is 1.5 kilometer. So I think I can use half again, sum of parallel side, which is t plus this length is t, multiplied by the height is 30. The result is 1,500. So just take 1,500 times 2 divided by 30 minus 30. The time taken is 70 seconds. So this is 70 now. Okay, when the car has been moving now for the 20 seconds, so we know that we are supposed to find the acceleration, but before you find acceleration, we find v. We need to find v. We know that distance traveled here is the same as distance traveled here, so let's just say that distance here is half. Again, I can use this length is 70 minus 20, which is 50. So we can use sum of parallel side, 30 plus 50. Your height is v. The result is still 1500. Okay, let's find out what's v. Let's take 1,500 times 2 divided by 80. There you go, 37.5. So if this v is 37.5, we can now find the acceleration. But the problem with the acceleration is that we don't know what is this, the time here and even the time here. But we do know that the acceleration is a here, and the acceleration of the motorcycle is 3 times the magnitude of the deceleration. That means this deceleration is 103a. There are many ways to look at it, but I think maybe we can find out the difference in the time between 50 and 30. 50 minus 30 gives us 20. Now we know if they have the same vertical height, the horizontal height here must be shorter, or should I say this one must be 3 times longer, so that when you take v over t, this will be v over 3t, such that the acceleration or the gradient of this line is actually 3 times less than the acceleration or the gradient of this line. But remember, this is negative. Since the question says the magnitude, so we just ignore the negative. And perhaps we can see that the total t here is 4. So we take 20 divided by 4 equals to 5. So this should be 25 here. This should be, if you subtract 15, it will be 55. Yeah. So that means if I want to find a, I'll just take 37.5 divided by the width, the length of the base here, which is 5. That will give us 7.5. Okay. Okay. Lastly, I need to find the displacement time graph for the motion of the car. Now, for the car, right, you can see this is velocity time graph. Displacement time graph is a little bit different, as in if this is a slanting line going with a positive gradient, your displacement should be a curve going upwards. Yeah, it must be a quadratic that's going upwards, because this gradient is positive. So the gradient of this curve is also increasing, because the gradient of displacement time is actually your velocity. Yeah, so the gradient is your velocity is increasing, the gradient of displacement time must also be increasing. Okay, let's start from 0 to 10. I need to find the displacement, and I can do that by finding the area under the graph for this part. So maybe I work out separately. The area under the graph will be half times base times height. Straight, yeah, increase 1 0 5 0 over here, and velocity is decreasing. Can you see that? Until the end of displacement time graph is decreasing until it becomes horizontal here, say at 1500, as your total distance traveled is 1.5 km. Alright, and this happens when d is 70. Okay, so there you go. That's your displacement in meter and the time in second. Yeah, displacement time graph for the motion of the car.